Investigating the effect of temperature on the rate of decay is a fundamental experiment that helps us understand how environmental conditions influence the breakdown of organic material. This investigation typically involves measuring the rate at which organic matter decomposes at different temperatures, providing insight into the optimal conditions for decay and the activity of decomposers such as bacteria and fungi. To conduct this experiment, you first need a sample of organic material that will undergo decay. A common choice is a mixture containing substances like fruit peel, grass clippings, or even milk, which can decompose relatively quickly and allow for measurable changes over a short period. You may also use a substance that contains a known amount of a specific compound, such as milk protein, casein, which breaks down during decay. The decay process is typically monitored by measuring a variable that changes as the material decomposes, such as pH, mass loss, or the production of carbon dioxide. Once you have your sample, the experiment is set up to expose the material to different temperatures. This can be done by placing the samples in water baths, incubators, or other controlled environments where the temperature can be precisely regulated. Common temperature settings might include a low temperature, such as 10 degrees Celsius, a moderate temperature, around 20 to 25 degrees Celsius, and a higher temperature, such as 40 degrees Celsius, to cover a range of conditions that might be encountered in natural environments. To monitor the rate of decay, you can measure the chosen variable at regular intervals. For instance, if you are using milk as the organic material, you might measure the change in pH over time, since the breakdown of proteins by bacteria produces acidic byproducts that lower the pH. Alternatively, you could measure the amount of carbon dioxide produced, which would require a setup where the gas emitted by the decomposing material can be captured and quantified, often using gas syringes or other collection methods. Mass loss of the organic material over time can also be measured by weighing the sample at intervals, which provides a direct measure of how much material has decayed. As the experiment progresses, you will typically observe that the rate of decay varies with temperature. Decomposition usually occurs more rapidly at higher temperatures, up to a point, because the metabolic activity of decomposers like bacteria and fungi increases with temperature. Enzymes that drive the decomposition process work more efficiently at optimal temperatures, leading to faster breakdown of organic material. However, if the temperature becomes too high, it can denature these enzymes and kill the microorganisms, slowing down or even halting decay. Similarly, at very low temperatures, the metabolic rates of decomposers slow down significantly, resulting in much slower decay. After collecting data across the different temperature settings, you can analyze the results to determine how temperature affects the rate of decay. This analysis might involve plotting the rate of decay, such as the amount of carbon dioxide produced or the change in pH, against temperature to visualize the relationship. The results typically show an increase in decay rate with rising temperature, up to an optimum point, after which the rate may decline if temperatures exceed the tolerance levels of the decomposers. This investigation not only provides valuable information about the conditions that influence decay but also has practical applications. Understanding how temperature affects decay can help in optimizing composting processes, controlling waste management systems, and even in forensic science, where decay rates are used to estimate the time since death in biological materials. In conclusion, investigating the effect of temperature on the rate of decay involves exposing organic material to different temperatures and monitoring the decomposition process over time. By measuring variables such as pH, mass loss, or carbon dioxide production, the experiment reveals how temperature influences the activity of decomposers and the breakdown of organic matter, offering insights into both natural and applied processes.